Hello again. Well, we're going to be working with everybody's least favorite trig graph, or the aspect of it probably, is the tangent of x, or tangent of theta, or for common purposes, sine of x over cosine of x. Tangent of theta, tangent of x is the same thing as the sine divided by the cosine. And that's why it's really tricky. Students don't seem to understand, or I mean they can do the sine, values of radians or degrees, or they can do the cosine of radians and degrees, but when they have to do both of them at the same time, it's pretty annoying, especially when you start working with phase shift, period, amplitude, vertical shift. I'm just going to give you a basic introduction to the tangent of theta, and then cotangent afterwards. Pretty cool. Not, terribly difficult, but a little annoying here. And what you have to keep in mind is that the tangent graph actually has asymptotes to it, vertical asymptotes. The sine and the cosine aren't limited in terms of domain, but the tangent is. So you have to watch out for that. With that said, let's go ahead and figure out what it is. Now, it's the sine value over the cosine value, and what students have a hard time understanding is this. How can I find out where it's undefined? And the answer is, where is the cosine and the sine, 0 and 1? That's probably the best way to start. So when I plug in 0 radians, I'm going to go ahead and do this first. I'm doing them both at the same time, but once you kind of memorize it, then it's not so bad. So the sine of 0 is 0, cosine of 0 is 1. Or radians, I'm assuming radians the whole time. So this one is 0 over 1, which comes out to 0. Pi over 4, sine of 45 degrees is root 2 over 2, divided by root 2 over 2. Root 2 over 2 divided by root 2 over 2 is just 1. That's why I like working with only aspects of 45 degrees, especially with the tangent. It just makes life so much simpler. When I use 90 degrees, the sine of 90 degrees is 1, but the cosine of 90 degrees is 0. Uh-oh, that's going to be undefined. When I do this one, it's root 2 over 2 it's root 2 over 2 divided by root 2 over 2. The problem is that the sine is positive, but the cosine is negative. So actually the answer is -1. And before you try to figure out anything really quickly, let's just do this as a refresher. All students take calculus, where all of them are positive in the first quadrant, only the sine is positive in the second quadrant, the tangent is positive in the third quadrant, the cosine is the only one positive in the fourth quadrant. So keep that in mind when we're doing this. When I do pi, the sine of pi is 0. The cosine of pi is -1. 0 over -1, no matter how many times you slice it, is 0. I've got 0 money around, there's -1, it doesn't matter. It's 0, there's nothing to give to anybody. 0 divided by -1 is 0. 5 pi over 4 is in the third quadrant, so that means that the tangent is positive. Sine of 3 pi over 2 is -1. Cosine of 3 pi over 2, or 270 degrees, is 0. So the -1 over 0 is undefined. It's as simple as that. 7 pi over 4, it's root 2 over 2 divided by root 2 over 2. The cosine is positive, but the sine is negative, so a negative divided by a positive is a negative. And 2 pi is the same thing as 0, so we're back at 0 over 1. So I'm going to go ahead and graph this bad boy as best as possible. But here's some things to take into consideration here. At pi over 2, the tangent is undefined. There's a vertical asymptote. So each one stands for pi over 4, so at pi over 2, it's undefined. At at 3 pi over 2, pardon me, or 6 pi over 4, 1, 2, 3, 4, 5, 6, tangent is undefined. So I like to draw the vertical asymptotes first. I just think it makes life a lot easier when we do that. Now let's try to figure out what happens here. At 0, it's 0. Whew. It's not all that easy though. At pi over 4, it's 1. At 3 pi over 4, it's -1. At 4 pi over 4, or pi, it's 0. At 5 pi over 4, it's 1. At 6 pi over 4, it's undefined. 7 pi over 4 is -1. Now what's really interesting is it's not a straight line that goes like this. What it is it's a curved line. If I took the tangent of 30 degrees and the tangent of 60 degrees, it'd be more obvious to see. But I don't like doing things in increments of 30 because I just think it makes it more difficult. So what I tell my students is, if you want to figure out what those values are, plug them in. However, if you want to look at what a tangent graph looks like, a parent tangent graph, here's what you do. Draw something like this, and that's it. Now here's what's really interesting. At this point it's 0, at this point it's 0, and it's going up. So if I show my students something like this, they say, what do you think this looks like? Like, oh, here it's -1. And even though I didn't write the table for it, at there it's undefined. So it looks like this. I'm like, yeah, you'd be right if you said that. And here, I do that twice more. I really want to. Which I do actually to prove a point. And it's at 1, and it looks something like that. So what happens is, this graph repeats, but it doesn't repeat every 2 pi, it repeats only at pi. You know, the period is half as long for a tangent graph that it is for a cosine, a sine, a secant, or a cosecant. So the period of a tangent graph is 2 pi. I'm going to go ahead and write that down right now. Well, what's the range of a tangent graph? Well, it goes from negative infinity to positive infinity. Well, that's easy. Oops. It's a 2 pi. Well, I can't correct that now, so if you heard it 25 seconds ago, disregard it. The period is pi. Pardon me. The period is pi. Okay, the range goes from negative infinity to infinity. Now the domain's really interesting because it doesn't include all aspects of the x values. It doesn't include pi over 2, it doesn't include 3 pi over 2, it doesn't include negative pi over 2. So basically, the domain includes negative infinity to positive infinity, except it does not include pi over 2, plus, and then every pi with an integer multiplied with it does not include. Every interval of pi after pi over 2. So 1 pi plus pi over 2, 2 pi plus pi over 2, 3 pi plus pi over 2, negative 1 pi plus pi over 2, negative 2 pi plus pi over 2, etc. It's the same domain that we did for, I can't remember if it was the secant or cosecant. I want to say it was the, what am I saying? It's the secant graph. There we go, because it's got the same denominator. Okay, so that's the period, that's the range, and that's the domain. So with that said, I hope that was helpful. What we're going to explore next is we're going to explore the cotangent graph and see how that works. The cotangent is the reciprocal function of tangent. So what I'm going to be doing is I'm going to be flipping all the values and seeing how that affects our graph. With that said, have a good day for right now. Goodbye.